Okay, guys, how are you? I hope you guys are good. Yeah, I'm just going to record this lesson. I'm in campus, University of Pretoria. Yeah, as you can see, it is so chill, like it is so quiet. Let me just show you. Just that I'm lazy to go outside. But then, yeah, I'm at University of Pretoria, the campus for teachers. Yeah, I think some of you know it. So yeah, but then without any waste of time, guys, let us start with our lesson. Our lesson today, it is based on Surds. Okay, which part is this one? I think it is part 7, right? Part 7 of Exponents and Surds. Part 7, right? And then our topic, it is Exponents and Surds. Exponents and Surds. And our subtopic being Surds. You know, we've been saying Surds without doing it. Okay, so today is our chance that we are going to do it. Okay, so before we do Surds, guys, there are a few things that I want you to understand that might be a prerequisite to you, for you to absorb this knowledge about Surds. Okay, so I want you guys to know what are perfect square numbers. Okay, what are perfect square numbers? Quickly, perfect square numbers. Perfect square numbers. Okay, so I'm going to show you what are perfect square numbers. So perfect square numbers are the numbers that you get when you square your integers. Okay, so if you say 1 squared, it is 1. 2 squared, it is 4. 3 squared, it is 9. 4 squared, it is 16. And 5 squared, it is 25. And 6 squared, it is 36. 7 squared, it is 49. Okay, and so on and so on. These are perfect square numbers. Okay, I want you guys to understand, to know, and remember what are perfect squares. So those are the few that I can list for you. They are main. Okay, so you can continue with that list of them. Okay, and then I also want you guys to remember what are perfect cube. Okay, perfect cube numbers. Okay, so perfect cube numbers are the numbers, once you say that 1 cube, it will give you 1. And you say 2 cube, it is 8. You say 3 cube, it is 27. Okay, and so on and so on. These are cube numbers. Okay, so this I want you guys to understand. Okay, perfect squares and perfect cubes. Remind yourself with these ones how to get them and then how do they work. Okay, because we are going to use them on this lesson of our Surds. Okay, so now what are Surds, guys? So Surds are the root signs of the numbers which are not perfect. Okay, what do I talk, or what do I refer to when I'm talking about the numbers which are not perfect? I'm referring to one, it is perfect. Remember, it can be a perfect cube, it can even be perfect squares. But then once you talk about 2, it's not perfect. You talk about 3, it's not perfect. You talk about 4, it is a perfect number. You talk about 5, it's not perfect, right? You talk about 6, it's not a perfect number. Am I right? Yes, 6 is not a perfect number. Okay, and so on and so on. So now, whenever we are talking about Surds, when a root is irrational, it is referred to as a Surd. Okay, when your root, it is irrational. Root is irrational. What do I mean when I say root can be irrational? So I simply mean that if you take the square root of 2, it's going to give you a decimal number. Okay, it's not the same as the root of 4. The root of 4, we know that it's 2. So this root, it is rational, but then this one, it's going to be irrational because of it will give you a decimal number. Okay, not only that, but then you can also try root 5. Same thing will happen. It will give you a decimal number. Okay, you would also try the cube root of 20. It will give you a number with decimals. Okay, so but then when we talk about the 4, the root 4, it gives you 2. So a root 4, it cannot be a set. Okay, so whenever we talk about a set, guys, we talk about a root of any number that will give you a decimal. Okay, simple as that. Any root that will give you a decimal, it is a set. Okay, it is a set. Okay, so the reason why I was talking about perfect cubes and perfect squares, I wanted to give you this lesson. Okay, so check now. If you have a cube root like this, and then you put a perfect cube under this cube root, like you put 8, it will definitely give you what? It will give you an integer. Okay, so cube root of 8, we know that it's 2. Okay, but then now, let's say a cube root of a number which is not an integer. Okay, so if we take a cube root of a number which is not an integer, let's make an which is not a perfect cube, I meant to say. Okay, a cube root of 4. Okay, it will give you a number that has decimals. Okay, you can press it on your calculator and see it. But then now, if we take the square root of 4, let us take the square root of 4. The square root of 4 gives you 2. Okay, why? Because of 4, it is a perfect square. And then we have a square root. So if you take a perfect square number and you put it under a square root, it will definitely give you an integer. And if you take a perfect cube number, you put it under a cube root, it will give you what? It will give you an integer. Okay, remember that our integers are 1, 2, 3, 4, 5, 6, 7. Okay, so it is very crucial. It is vital for you to revise what are integers. Okay, so cool, guys. Then let us start with our sets now. We have 2 laws about the sets. Okay, so we have 2 laws about the sets that I want to share with you today. So the first law, law number 1, it applies like this. So whenever you are having something like let's say that you have the root sign, 2 of them like this, okay, and B, okay, you are allowed to join them and make them, put them under the same root sign like that. That's the first law, okay, of sets. And the second law of sets, it is when you are dividing them. You can even take a guess on that one. When you are dividing them like that, you are also allowed to say that this thing, put them under the same root sign, and then A divided by B. Okay, why are we doing this? Because of they share a common root. Okay, a root of n, even here we have a root of n. So if they share a common root, you can put them under the same root. I hope I'm making sense so far. And then, now, let's quickly take an example. Okay, example 9, to apply this thing. And then remember, if you do this, you must also know the reverse of it, right? So let's say that you are given this. Let me use y, not n. Okay, then you can take it to, you can make it this. Okay, This is a reversal of what we have learned earlier. Also, if you are given this P divided by Q, you can simply take it and make it A exponent, the root of A divided by, the root of 8th root of P and divide by 8th root of Q, like that. Okay, so you must know the forward procedure and the backward procedure. Okay, so quickly, without any waste of time, let us take example. Okay, so example 9. Example 9. So on example 9, we have A. We have the root of 2 times the root of 3. Okay, so if you have this, guys, you are simply allowed to say that these two things, they share the common root, and then you are multiplying. So take one root, okay, because of they share the common root. Take that root to represent the two of them, and then just put those numbers under. Okay, and this will simplify to be the root of 6. Okay, so B, if you have root 3 over root 3. Okay, so remember this thing are sets, guys. Okay, so we said the sets are what? Sets are the roots of irrational number. Irrational roots. Okay, so what do we mean by irrational roots? That those root sign, when we take the root sign of each, it doesn't give us an integer, it gives us a number with a decimal. Okay, root 3, if you take it, it will give you a number with a what? It will give you a number with a decimal. Okay, even this one, it will give you a number with a decimal. But then now, once we apply the law of sets that we have learned above, you will say that root 3, it is the same as root 3. Because of they are the same, you can take one root and you take the numbers like that. Okay, then you notice that will start to give you the root of 9. And then the root of 9, it is the same as 3. So far, so good. C, if we have a root of 4 like that, okay, all squared. Okay, so this is the same as A squared. A squared means what? Means A times A. Right? Do we agree? Yes. So even here, root of 4 all squared, it means root of 4 times root of 4. Okay, and then root of 4 times root of 4, you can take one root and then you put your numbers under the root sign there, and then the root of 4 times 4, it is how much? It is the root of 16. And then the root of 16, it is the same as what, class? It is the same as 4. Okay? See, then let's go to D quickly. D. Then for D, we have root of 27 all divided by root 3. Okay? So you are more than welcome to put them under the same square root. All right? So 27 there divided by 3. Okay, so under the square root, you will notice that 27 divided by 3, it is the same as what? 27 divided by 3, it is the same as 9. Okay, 3 goes into 27 9 times. And then the square root of 9, it is the same as 3. Okay, so guys, I'm moving very fast. So whenever you watch this video, you are more than welcome to pause it to make sure that you understand every detail I'm saying there. Okay, so let's do E. The last one for this example. E, we have the cube root of 16 all divided by the cube root of 2. Okay, so you notice that these things, when you tackle them alone, individually, if you might try to tackle the numerator by itself, it will not work out. If you try to tackle the denominator by itself, it will not work out. But then now, since we know the laws of the sets, we can apply them. So since the root sign are the same, you see, we have the common root sign for both of for the numerator and the denominator. So you are allowed, or you are welcome, to take one root sign and then put 16 and 2 over them. Okay, this is the law number 2 that we are applying here. And then we know that 16 divided by 2, it is 8. Okay, and then we know that the cube root of 8 exists. And then it is what? The cube root of 8, it is 2. Okay, hope you get this, and then they are simple as they are supposed to be. Okay, so, and fun as well. Okay, so now example 10. Example 10, it is about adding and subtraction of sets. Okay, please do not confuse the laws for multiplication and what? Multiplication and division of the sets. Okay, so what we did so far, it was about multiplication and division of the sets. Okay, but then now what we are going to do, we are going to add and subtract sets. Okay, add and subtract sets. Okay, that's what we are going to do at the moment. Quickly, let us take the first example. So A, you have 5 root 3 plus 2 root 3 minus 3 root 3. Okay, so now I just want to bring it to your attention. Like, if you have 5 bananas plus 2 bananas minus 3 bananas, your answer becomes 5 plus 2 bananas. It will give you 7 bananas. When you subtract 3 bananas, you end up remaining with 4 bananas. Okay, so I hope you get this analogy. So here it's a matter of adding your numbers, and then you explain, you just put the banana because of you are talking about bananas. You are not only talking about the numbers. I hope you get this analogy. If you get this analogy, then it will be simple for you to add and subtract sets. Okay, so quickly let us do this one. So this root 3, you see, it is root 3 here, it is root 3 here, it is root 3 here. So you are going to approach it like you are adding 5, okay, you have 5 root 3s, this, it's here, no? You have 5 root 3s and 2 root 3s, and you're subtracting 3 root 3s. Okay, so 5 root 3 plus 2 root 3, it gives you 7 root 3s. And then once you subtract 3 root 3s from 7 root 3s that you had, you are going to remain with 4 root 3. I hope it made sense. B, you have 7 plus 2 root 7 minus 6 root 7. Okay, so here you have a group of root 7s. Okay, so here it is 1, and then here they are 2. Okay, so if you add 1 and you add 2 of these ones, they are going to be 3. And then once you have 3 of them and then you subtract 6, for you to be able to subtract 6, you are owing them the 3 of them. So this minus, it simply shows that you owe them 3 root 7. Okay? Or you can just simply press your calculator and you will get this. But then I want you to understand this. Okay, so let us analyze this. Let's say that you have a bucket like this. Ne? So in that bucket, what's happening is that you are having you are having, like, remember we said root, this is 1 root 7 and then this is 2 root 7. So we are having 3 root 7. And they want to come and borrow 6 of them. So when I talk about borrow, I'm talking about this minus. So minus means that we want to borrow 6 of them, but then they only have 3. So how many are they going to? Okay, they are going to give us 3. And then how many will they short so that they can meet our needs? So it simply means that they are in short of 4 of them to meet what? To meet our needs. Okay, so minus, I'm sorry, here it was supposed to be 4. Minus 4 root 7. So this minus, it shows that they are in short of those ones. Okay, so but then beside that, you can use a calculator. Here it is your homework. Please screenshot it. I just to put it randomly this time so that I can get those who just browse and then forward the video so that they can go straight to the homework. Okay, so our homework is here. Screenshot it, and then the last part of our homework, screenshot this, and then yeah, it's complete here. Then screenshot this last ones, and then it's complete. This is our homework or our exercise that you are supposed to do. Okay, please don't try to be clever and decide that when you are not going to watch this video and then you are just going to do homework. You are robbing yourself. From experience, I noticed that every time we are trying to be clever and trying to rob the system, most of the time it is us who get robbed. Okay, so let us do our C, example C there. So example C, it's like this: root 3 of 5 plus 5 root 3 of 5 minus 2 root 3 of 5. Okay, so notice that this time we are talking about the root 3s of 5. Okay, we are talking about cube root, I'm sorry guys, cube roots of 5. Okay, so we are having cube roots of 5. We are talking about the group of cube roots of 5. Okay, so here you have 1, here you have 5, there you have 2 of them. Okay, so 1 plus 5, it is 6, right? And 6 minus 2, it is 4. So you're having 4 of what? Of this group of things that we are talking about, which are cube roots of 5. Your answer is simply as that. Okay, so quickly let us jump to example 11. Okay, so number 1, you have root of 18. Okay, so how do you deal with root of 18? You see, there we were just adding and multiplying. We were adding, multiplying, subtracting, and dividing. Okay, so now we are given root 18. Then we need to factorize it. Okay, how are we going to factor it out? So simply you are going to say that 18, guys. Okay, 18, it is the same as 9 times 2. Right? 9 and 2 are the factors of 18. But then now the question is that why did I choose 9? Okay, why didn't I choose, what can we choose the factors of 18? 6 times 3. Okay, the reason why I didn't choose 6 times 3 and why I choose 9 times 2, let us make a comparison quickly. Why did I choose this? So I chose this because I know that 9, it is a perfect square number, and here we are talking about the square root. Okay, so merely because we have a square root, and then we have a square root of 18. So for me, it will be convenient for me to choose a number that is a perfect square. Perfect square, I match it with the square root. Okay, 6 and 3, it was still going to be complicated as it was, because of this is not a perfect square, and that one is not a perfect square as well. Okay, I hope you get this. Okay, that's why I use 9 and 2. Okay, so then it simplified to become root of 9 times root of 2, like that. Okay, This is the reverse of what we've been doing earlier when we were dividing and multiplying the exponent, okay? And the root of 9 is 3. Then root of 2, it is root of 2. It does not change. Okay? So then it becomes 3 root 2. Okay? Let's take another example. Hope this one, it will open your eyes wider. Whatever that you fail to understand earlier on, I assume that you will understand this one. Sorry. So let's say that you have root 8. Root 8. What's going to happen with root 8? So I'm going to choose 4 and 2. Why 4 and 2? Because of 4, it is a perfect number. Okay, remember guys, we did perfect, it's a perfect square number. We did perfect square number earlier on. That was the reason why we were doing them. Okay, so 4 multiplied by 2. Okay, why? Because of 4, it's a perfect square number, and then we are dealing with the square root of that. Okay, so the square root of 4 times the square root of 2. Then this simply becomes 2 root 2. Simply like that. Of course, they might seem to be very difficult to you, but then the more you practice, the easier they will get. Okay, so let's go to number 3. Okay, cube root of 54. Okay, so now notice that I have a cube root. It's not a square root anymore. So it simply means that for the cube root, guys, I will need a perfect cube number, okay, to multiply it with something to give me 54. Why? Because of we have a cube root there. So cube root of 54, right? So how can I write 54 as a perfect cube? So I can write it as 27 multiplied by 2. Why? Because of I know that 27, it is a perfect cube. Okay, so then you say that the cube root of 27 times the cube root of 2, right? And your answer will be the cube root of 27. It is how much, guys? I think it is 3. And then the cube root of 2 will remain like that. It is a surd. Okay, so far so good. I guess we get to understand this. Let's go to B. Root 12 plus 4 root 75. Okay, so now I am going to mix those rules. Okay, the one that you have learned with the addition, the one that you have learned about multiplication and division, and the ones that you have learned about subtraction and addition. Okay, so I will write a 12 using a perfect square number. Why? Because of I have a square root there. So 12, I'm going to write it as 3 times 4. Are we together, guys? And then now 4 plus 4, I'm sorry about that, plus 4. Now 75, it is under the square root. Okay, so I will also try to write it as with a perfect square number. Okay, so 25 times 3. Okay, then quickly root, in fact, I should have said 4 times 3. Okay, so root of 4 times root of 3 plus 4. Now be careful, this one you separate it because of it had 4 already there, and then this 4, it belongs to everything. That's why I put this thing in the brackets. Okay, so root 25 times root 3. Because of if I wrote it without this bracket, it was going to be as if this 4, it only belongs to root 25. I hope I'm making sense on that one. Then you quickly say root 4, it is 2. Root 3, it is a surd, it remains like that. Plus 4, root 25, what is root 25, guys? Root 25, it is 5. And then root 3, it remains root 3 like that. Okay, so then now you can simply say that 2 root 3, 4 times 5. Okay, this times that, it becomes 20 root 3. Okay, so now this is so beautiful, guys. I love math. Math is so beautiful. So root 3 and root 3. So now you are dealing about the group of root 3s. Okay, these are root 3s. Okay, but then here we have 2 of them. There we have 20 of them. Okay, and then how do you deal with them? You just add your numbers, 2 and 20. 2 plus 20, it gives you 22. Right? And then root 3 and root 3, you are talking about root 3s. Okay? So 22 root 3s. I hope this made sense. And then let me quickly do number. I hope that this video was going to be very short, but it seems to be very long. It's okay. So 2 plus 3 root 2 all squared. Okay, so how do you deal with this one? You know that this simply means that you have 2 things of this. That squared means that you have 2 things of this. So let us write 2 things of that. Okay, like that. Okay, then you are going to apply your FOIL. I don't know how many of you still remember FOIL from grade 10. 2 times 2, it is 4. 2 times 3 root 2, it is 6 root 2. 3 root 2 times 2, it is 6 root 2. 3 root 2 times 3 root 2, it is 9 root 2. Okay? Then this will simplify to be 4. These ones are the same, will give us 12 of root 2s plus 9 of root 2s. Okay, then now we have 4 plus. Okay? So 12 of root 2s plus 9 root 2s. So 12 plus 9, it is 21 of root 2s. Simply like that, okay? But then it seems like I have just made a mistake somewhere. I don't know where. But then let me just try to go through it again. So 2 times 2, it is 4. 2 times 3 root 2, it is 6 root 2, and then that it is 6 root 2 plus 9. Okay, so here guys, I'm really sorry. So if you say 3 root 2 times 3 root 2, hey, this one guys, it's very challenging. Okay, so this, it is the same as 3 root 2 all squared. Okay, and then that 3 root 2 all squared, it is the same as I'm sorry guys. Okay, yeah, I think I'm supposed to delete this one as well. Yeah. Okay, so guys, I'm really sorry about that. Let me just restart it. 2 times 2, 4. 2 times that, 6 root 2. Right? 3 times this plus 6 root 2. This and that one there. Okay, I was supposed to write it here. So it is the same as 3 root 2 all squared. Okay, and then we know that this ones, they add up to 12. And then that one, if you simplify it, 3 squared, it is 9. Root 2 like that squared. This squared will cancel that. Then 9 times 2. Right? Like that. Okay? Then 4 plus 12 root 2. 9 times 2, it is 18. Then your answer becomes 4 plus 18, it is 22. Plus 12 root 2. Hope you get to understand it, guys. Yeah, it was just a minor challenge there. And then let's do 3 and 4. root of 48 minus root 3 over root 27. Okay, so this one is nothing. We know how to deal with these things. So the first thing, 48, guys, we must change it to become a number that is made of a perfect square number. Why? Because we have a square root, right? So we are going to use 16 times 3 like that for that one, minus root 3. This one is a set. Let's just leave it the way it is. 27, we must also, because of it's a square root here, we must also try to use the square number, 9 times 3. Okay, so 9 is a square number, a perfect square number. Okay, so the square root of 16 times square root of 3 minus root 3, all divided by square root of 9 times square root of 3. Okay, it is equals to square root of 16, guys. What is the square root of 16? The square root of 16, it is the same as 4 times root 3. Okay, it's a set, that one. Let's just leave it the way it is, minus root 3. And the square root of 9, it is 3. This one is a set as it is, root 3. Okay? Then this will simply simplify to 4. We are talking about root 3s here. Okay, so we are having root 3s, 4 of them, and then we are subtracting 1. So we will remain with 3 of them for our numerator. And for our denominator, we had 3 of them. Okay? So anything divided by itself, it is 1, guys. Anything divided by itself, it is always 1. The last one, guys, let us do this one. Square root of 4x exponent 9 minus square root of 16x exponent 9, all of them divided by square root of x. Okay, so now where do we start, guys? We know that this can simply be written as square root of 4 times square root of x exponent 9 minus square root of 16 times root of x exponent 9, right? All of them divided by root of x. Then the root of 4, it is 2. And then this one, this one, guys, we can decide to change it and write it as, we can decide to use the, what do we call that? Rational exponents. Remember when we did the rational exponents in a previous video? We can write this as x exponent 9 over 2. I hope you guys remember that. Square root of 16, it is 4, right? Times x exponent 9 over 2, like that. Okay? All of them divided by x exponent 1 over 2. So I wrote this one as, I wrote root x as x exponent 1 over 2. I'm reminding you guys about the rational exponents that we did earlier on. I wonder if you still remember this. I feel sorry for you guys. But then you must watch those videos various times, because of those things are new to your mind. So for you to understand them, for you to be able to enjoy this, like, you just need to watch them at least 4 times each, and then you must pay attention. Okay, so 2x exponent 9 over 2 minus 4x exponent 9 over 2, all of them divided by x exponent 1 over 2. Okay, so just notice that here you are dealing with what? You are dealing with x exponent 9 over 2, x exponent 9 over 2. So If you have 2 of them and you subtract 4 of them, you will remain with minus 2 of what? Of those x exponent 9 over 2. Okay, all divided by x exponent 1 over 2. Okay? So, and then, what's going to happen here? This will end up here. Okay, minus 2. This and this, we apply the rules that says that dividing the powers of the same base, take one base and subtract the exponent. You see how all those rules came back here. Okay, so then your answer will simply be minus 2, 9 over 2. If you say 9 over 2 minus 1 over 2, it will give you 4. Then you are done. Okay, let's say that you didn't like how we tackled this one from here. Okay, so you could have simply said, simply took it as like the root, guys. You know the way of the roots. Okay, just screenshot this one, and then, okay, in fact, let me take it from here with a different method. Ne? Let me just try something. I've seen it somewhere. Let me try that, guys. Okay, let me see. Maybe it will work. Copy. Oh yeah, it seems like it's working. I just want to do it with a different method from there. I don't know how to paste it, guys. How do we paste it well? Guys, I'm struggling to paste that thing, but then I will learn that. So what I'm simply trying to say is that, okay, let me erase this one and then follow a different method. Okay, so you could have simply said that root 4, it is the same as 2 x exponent 9, like that. Root 16, it is the same as 4, yes, x exponent 9, like that. And then root x, okay? And then from here, you simply say that you are dealing with the root sign of x exponent 9. You are having 2 and you are subtracting 4 of them, okay? So your answer will be minus 2 of what? Of root of x exponent 9. All of them divided by root of x. Okay? So, but then either way, guys, for your things to be simple, just apply those laws on rational exponents. Okay, so minus 2. So that one I'm going to write it as x exponent 9 over 2. And then this one I'm going to write it as x exponent 1 over 2. Right? And then what does it become? It becomes minus 2. Dividing the powers of the same base, subtract the exponent, 9 over 2 minus 1 over 2. Then there your answer will simply be 9 over 2 minus 1 over 2 will simply give you x exponent 4, simply like that. Thank you, guys. Yeah, I hope you enjoyed. Please, when you watch this video, make sure that you pause so that you can digest this information that I'm sharing with you. Okay, so just by that, guys, we are done by Surds. Okay, only in one video. So we have managed to put everything under the same video on Surds. Okay, so watch them as much as you can. Watch this video at least 5 times. And then I wish you all the best. And then remember that we have an exercise or homework that I gave there at the beginning. So if you didn't watch this video, you just jumped, you just fast forwarded, know that you won't get the video the exercise that I'm talking about. Okay, guys, keep well. Bye-bye.